quick update on the Spectral calibration and response subsystem. I'm gonna take a seat for this one. So what we got here is a couple different sensors going on. I sent out the schematic of what I had going on, but I got an ML8511 UV sensor. I've got an analog sensor here that takes basically what you're reading, converts it to an analog. It does an analog to digital conversion. So it takes the analog data, goes in through some of the analog ports here on the microcontroller. I got some code in there to do some nifty math and convert that to index measurements in terms of the voltage, converting it to the index. So this TSL2561 lux sensor is supposed to be calibrated within the band of solely visible wavelengths of light. The 2591 here can do visible plus IR. So when I power this up, it'll be the bottom one here that gives you all that data. Now I've got another ML8511 here, but for some reason I just cannot get any of these 8511s to give me accurate data. And I'll show why here in a second when I plug this in. So it'll go through the process just like everything and initialize it. So my analog is, I mean, it kind of works, but it's iffy at best. And I don't really like it because I can take things here and try to block them and it really doesn't change. I don't know if I'm getting all the most accurate measurements. My UV measurement here on the side. Again, so what I think I'm gonna do is the TSL2591 is giving me really good, this is all in lux by the way, and I can just kind of shadow that up and it's very responsive. I think it's gonna be a great breakout to have, but what I'm gonna do here is if I can clean it up, I'll do it. So I'm gonna take these three sensors and there's a new sensor that just came out. It's a UVA, UVB, and UV index sensor. It's a VEML 6075 surrounded around that op amp. It's a breakout, and I can use these two sensors, clean up this entire display, and then only have those two sensors. I don't have to make the scars an independent subsystem. What I can do then is take the data that I'm getting and just add it to my photocurrent measurement system, which would be great. This way I can have all that data logged as well. So when I do all my calculations and such, I can have really nice graphs to show for it. So that's where I'm at right now. This is probably one of the last things I'm gonna do before I start really hammering down on the PCMS. Like I'm still waiting on parts, but a couple of other things to work on over here. I got some new voltage sensors, so I don't have to really build my own. And I'm still working on that current sensor that'll really help me. And to give you an idea of scale, this is my shunt resistor. So pretty big, but that's the cost, I think, of some really accurate measurements on the solar system or in the solar array, which I'm still planning on using this for testing. So as always, any questions, please feel free to shoot me an email. Thank you.